Hello students, welcome back to your science class. So students, in the previous class we were talking about that of the Mendelife's law, and we have seen that what are the different kind of the laws which was given in order to classify the different elements. And in that we had started with that of the Menlife periodic table. We have understood the Newland's law of octaves and the limitations for that of the Newland's law of octaves. Then we started to understand that of the Menlife periodic law, student, and we have seen that it basically classified on the basis of the atomic masses. And also we have seen that why this Menlife periodic table was accepted widely, what is the reason behind it, as well as what are the different limitations of that of the Menlife periodic table or that of the Menlife periodic law. Okay, now if we talk about we already had discussed about the achievement, and now we will going to understand that of the limitations also. Talking about the limitations, so what are the different limitations are there? So now you see here the limitations of the Menlife classification, and the first one, when we look at the electronic configuration. So electronic configuration of that of the hydrogen, students, as you can see here, that what happened in case of if we talk about the electronic configuration of a hydrogen, it was very much similar to that of the alkalis. So like alkali metal, hydrogen also combines with that of the halogen. It combined with oxygen and that of the sulfur to form compounds, and these all are having the similar formula. When you look at the compound of the hydrogen, it is what, when it will combine with that of the alkali metals, you can see here, or with that of the other metals, you used to see that the compounds can be easily formed with that, or most of the compound can be formed with that of the hydrogen, whether it is chlorine, oxygen, sulfur, or even with that of the sodium also. So you can see here that hydrogen here showing the same kind of a compound formation like that of an alkali is showing. Okay, so you can see here the alkali metal as well as the hydrogen, both of them are forming the same kind of a compound here. On the other hand, if we talk about that of the halogens, so like halogen also exists in the diatomic form, and it will also combine with that of the halogens easily. Now you see here the hydrogen used to show some of the properties like the halogens used to show. Let me tell you, the halogens are what, like fluorine, chlorine, bromine, iodine. These all are what? These all are the halogens itself. So the hydrogen, it combines, it used to show the properties of both of that of the alkali metal as well as that of the halogens here. It means these are able to combine with the metals as well as with the non-metals and forms the covalent compound. Certainly, if we talk about that of the hydrogen here, so hydrogen is kept on that of the alkali metal. So by this we can say that even in the Menlife periodic table, when you look at it, you will find that it is kept on that of the alkali metals, but it used to show the property of the halo group also. So there was no such specific position has been specified by that of the hydrogen in which it will going to show the property of both, that is alkali and halo group. So this is the first demerit, first limitation of the Menlife periodic table, in which he does not gives the correct position of that of the hydrogen here. The second one is the position of the isotopes. As you can see that the Menlife periodic table has been classified on the basis of the atomic masses. Talking about the atomic masses, students, so there are different kind of isotopes are there. What are isotopes? Isotopes are what in which the element with the same atomic number but different atomic masses are called as the isotopes. Like if we talk about the calcium, so calcium whose atomic number is 20 but in atomic mass is what, that is 35, and sorry, it is about that of the chlorine. So chlorine is there whose atomic number is 17, so it is about 35, and chlorine also exists in the form of a 37. Similarly, if we talk about that of the hydrogen, which is atomic number is 1, but hydrogen atomic mass is 1, deuterium whose atomic number is 1 again, whose atomic mass is 2, and similarly tritium whose atomic number is 1 but its atomic mass is 3. Next one, like that of the oxygen is there. So oxygen whose atomic number is what, that is 8, and its atomic mass is what, it is 16, and that of the oxygen 18 also exists. So both of them having the same atomic number but different atomic mass, and this is what these are called as the isotopes. Okay, so isotope of oxygen is there, isotope of a chlorine is there, then isotope of a hydrogen is there. If we talk about the carbon also exists in the form of a carbon 12 and carbon 14. Okay, so carbon is there. So these all are what, having the same atomic number but different atomic masses. They are the isotope itself. So they are having the similar chemical properties but they are having the different atomic masses. So why this is not, these elements are not placed, the isotopes are not placed in that of the Menlife periodic table, because the Menlife periodic table has been classified on the basis of the atomic masses. So they, although they are the same element but they are having different atomic masses, so there must be a position of the isotopes, but the position of the isotope was not specified. So this is the second challenge, this is the second limitation of that of the Menlife periodic table, in which the position of the isotope was also not specified. Another problem was there that the atomic masses what, they do not increases in a regular manner when we go from one element to the other, and it was not explained properly that why the atomic masses of the sum of the element was kept earlier than the element whose atomic masses are higher. Okay. Here at that time students, only 63 elements were discovered, but later on when the heavy elements were discovered, so it was difficult to put that means what will be the position of the heavier elements. So these are some of the demerits or some of the challenges which is faced by that of the Menlife periodic table. Okay, so the first one is the position of a hydrogen was not mentioned. The second one is the position of the isotope. The third one, the some of the elements are kept earlier even though its atomic mass is higher. Now moving on and see the next one. Next one is what? That is the modern periodic table. So, what is a modern periodic table? Actually, it was given by Henry Moseley, and the division was on the basis of the atomic number, and the Menlife periodic law was adopted as a means it's a kind of because of the Menlife periodic law only the modern periodic table came, and the division in case of a Menlife periodic table, it was on the basis of atomic mass, but in case of a modern periodic table, the division was on the basis of the atomic number. Okay, so now you can see here it is written that is the modern periodic table and the modern periodic law. Modern periodic table, it was given by Henry Moseley, and the modern periodic law was the modern periodic law state as follow: property of an element are a periodic function of their atomic number. Property of the element are the periodic function of the atomic number. That was what it is, the modern periodic law. Now, if we talk about the atomic number, students, so atomic number gives us the number of proton in the nucleus of the atom, and it increases when we move from one element to the next. So elements when arranged according to the increasing atomic number, it will help us in giving that of the modern periodic table. Okay, so now the elements are kept in an increasing atomic number. Okay, now the problems which was there, that the demerits, the limitations which was faced by that of the Menlife, it was very much eradicated with the help of the modern periodic table. The first one is, that is, here there is the problem of the position of the isotope is rectified, because now the division, the classification has been done on the basis of the atomic number, not on the basis of the atomic mass. Okay, so the elements, every element is having their own one unique atomic number. They are not classified on the basis of the atomic mass. So even though they belongs to different kind of isotopes they have, but they have been kept in a one slot. Okay, but the problem remains the same, and yes, every element is arranged in a proper increasing atomic number, so their property also remains the same. There was no such a problem occur with that of the property. Now you see here, if we talk about that of the hydrogen, so the hydrogen, even though it was kept at that of the alkali metal, but it do not belongs to the alkali, because it used to show the property of the alkali as well as that of the halo groups. That's why it was kept on the top of the modern periodic table. There was no such it is not included in that of the lithium family or in that of the alkali family. Okay, because it shows the both of the property. So question is that how were the position of the cobalt and nickel resolved in the modern periodic table? So now the modern periodic table is divided into the on the basis of the atomic number. So there is no such issues can be seen, and the cobalt and the nickel, they were kept now properly. Next one, how were the position of the isotope of the various element decided in the modern periodic table? Again, the atomic isotope is what, that is having the same atomic number but different atomic masses, and the division has been done on the basis of the atomic masses. So obviously the isotopes were placed properly. Is it possible to have an element with atomic number 1.5 placed between hydrogen and helium? No. Every element is having the unique, and they do not they do not have any kind of a prox or a decimal value, but a proper number has been provided to each of them. Where do you think that hydrogen should hydrogen be placed in the modern periodic table? Actually, in the modern periodic table, hydrogen has been kept on the top of the table. Okay, and there was no such a specific position has been given even in the modern periodic table. Although it is kept, we can say it is kept on the top of that of the alkali metal, but it do not belong particularly to that of the alkali metal only. Now you can see here, this is that of the modern periodic table, student, in which there, as you can see here, that group number and periods are there. There are 7 periods are there, student, and when you look at the group, so there are 18 groups are there, and out of that the 2 is there in between, transition metal is there, then lanthanoids are there, actinoids are there. Now moving on, and we will see that what are the position of the element in the modern periodic table. As you can see here, it is written that in case of a modern periodic table, 8 vertical columns are known, and these vertical columns are known as groups, while 7 horizontal rows are there, and these 7 horizontal rows are called as periods. Now when you look at the group 1 of the modern periodic table and the name of the element present in it. Write down the electronic configuration of the first 3 elements of a group 1. So group 1 actually it consisting of a lithium, sodium and potassium. So here lithium will be divided into 2 1 because its atomic number is 3. In case of a sodium, it is lithium is there, students, then sodium is there, and then potassium is there. Lithium, it is 2 3. In case of a sodium, it is 2 8 1. One more thing. In case of a lithium, it is 2 1. In case of a sodium, it is 2 8 1. While in case of a potassium, it is 2 8 8 1. Because the lithium, its atomic number is 3, the sodium, its atomic number is 11, and potassium, its atomic number is 19. So when we divide it, we will get that all of them, the electronic configuration, all of them are having the one valence electron. So the next question is the same, that what similarity do you find in the electronic configuration? So the similarity that you find in this electronic configuration, that everyone is having the one valence electron in it. Okay, and so 18 vertical columns are there, which is known as groups, and 7 horizontal rows are there, which is known as periods. Now let us decide that placing of an element in a certain group and that of the period here. Okay, now how many valence electrons are present in the 3 elements? So valence electron is 1, because the configuration is 2 1 2 8 1 or 2 8 8 1. So valence electron will also be equals to 1 only. Now if we have to find the elements which is present in a group and the valence electron in it, for example, if we talk about fluorine, chlorine, so fluorine, chlorine, it is what, it belongs to 17th group, and here the division is also, if we talk about fluorine, fluorine is equals to 2 7, while in case of a chlorine, that is equals to 2 8 7. So one is 9 and the other one is 17. Okay, so the outermost shell is having the 7 electron and it need one more electron to complete its octet. So the number of shells, when we goes down, the number of shells increases, while in case of when we move from left to right, the same number of shell will going to include the different number of electrons present in it. Okay, so this is some of the divisions, some of the things which was explained by that of the modern periodic table, and it explained about that of the shells which is present in that of the different elements, and these shells are what, that is K, L and M. Okay, as you can see here, it is written that modern periodic the electrons in the atom of the elements are filled in K, L and M shell. So electronic configuration is actually, we used to use this shells only, which is K, L and M. Now you can see here, it is written here that we can explain the number of elements in the period based on how electrons are filled into various shells. You will study the details of this in higher classes. Recall that the maximum number of electrons that can be accommodated in a shell depends on the formula. Remember that when we were talking about the shells, students, the number of electrons that can be accommodated by different shells present in that of the periodic table, obviously there was K, L, M and N shell was there. So if we talk about the K shell, as you can see here, the formula is 2n square and the shell is the first shell. So putting the value of the 1 here, we will get the number of electrons is what, that is 2. Similarly, when you look at the elements which are present, the first element, first period element is what, that is 2 elements. Then the second one is the L shell, and the L shell is the second period. So second period is what, it consisting of the 8 electron, because again putting the value here, 2 into 2 square, and this will be equals to 8. So the second period is what, it is having the 8 electron. The first period is having 2 electron, the second period is having the 8 electron. Talking about the third, fourth, fifth, sixth and seventh period. So third is what, it is having the 8 electron, fourth is having 18, because right now the number of electrons present in it will be 18 only, because we will use here 3. Then fourth, fifth is also 18, 6th is 32, 7th is also a period which is also 32 here. Okay, so these all of the things, how the number of electron become this and this, we will going to study in the higher section here. Now let us move on and try to understand the trends in that of the modern periodic table. Here when we talk about the trends of students, Actually, we are discussing here, we will going to discuss that what are the different ways by which the number of electrons or when we move from left to right or when we move from up to down, then the things varies. So as we know here that the number of a valence electron decides the valency. Okay, so we have seen that whenever we are going to determine the valency of an element, we used to see the number of a valence electron present in that of the element. Talking about if any of the, if suppose we will take an example of a beryllium, you know that the atomic number of that of the beryllium is what? That is 4. Okay, so it's beryllium, its atomic number is 4, and when we do the electronic configuration, so the electronic configuration of that of the beryllium is what? It will be equals to 2, 2. So the number of the valence electron present in that of the beryllium will be equals to 2 here. So right now the valency will also be equals to 2. Remember that if the valence electron is up to 0 to 4, so the number of the valence electron will be equals to the valency only. But if the valence electron is more than 4, then we use a formula, and that is 8 minus number of valence electron. 8 minus number of valence electron. Okay, so if the valence electron is 1, valency will be 1. If the valence electron is 2, valency will be 2. If the valence electron is 3, valency will be 3. If the valence electron is 4, valency will also be 4. But if the valence electron is 5, at that time the number of valence electron is more than 4. So we will going to use this formula, that is 8 minus number of valence electron. And right now 8 minus 5 will be equals to 3. So the number of a then the valency it will be equals to 3, although the valence electron is 5 here. Similarly, if we see the number of a valence electron is 7. So it is more than that of 4, so we will use the formula 8 minus number of valence electron, and number of valence electron is 7, so the valency will be equals to 1 here. Okay, so we can say here that in such cases the valency is what? It will be determined with the help of the valence electron. Now you can see here there are some questions regarding that. Let us see what are the different questions. So how do you calculate the valency of an element from its electronic configuration? Yes, we are able to calculate it. How? The electronic configuration, if the number of valence electron in case of this is more than that of the 4, then the valency will be 8 minus the number of valence electron, and if it is less than that of the 4, so the valency will be equals to valence electron. Okay, so electronic configuration help us in telling the number of valence electron, and with the help of the valence electron we are able to find out the valency also. Now suppose the question is that what is the valency of a magnesium with atomic number 12 and the sulfur with atomic number 16? So valency of a magnesium, it is 12 students, so 12, so that will be equals to 282. So the outermost shell, the valence electron is 2 here. While in case of the sulfur, the outermost shell is having the valence electron, that is 16. So here the electronic configuration will be 286. So obviously it is more than that of the 4. So 8 minus 6 will be equals to 2. So the valency of the magnesium as well as that of the sulfur, it will be equals to 2 only. The difference is that in case of a magnesium, electronic configuration is 282. So it is less than that of the 4. So simply we will take here 2. But in case of the sulfur, it is 6, which is more than that of the 4. So we will going to minus it with that of the 8, and again we will get the valency, that is 2. Similarly, find out the valency of the first 20 element. Yes, with the help of the number of valence electron we will be able to find out. You must write the electronic configuration and then find the valency easily. How does the valency vary in the period on going from left to right? So when we move from left to right, at first the valency increases to 4. Like lithium is there, beryllium is there, boron is there, then carbon is there. So it will start it from here, and then nitrogen, oxygen, fluorine is there. So it will going to lose again. So at first it will increases and then it decreases. How does the valency vary in a going down a group? So valency does not vary in a group. The number of valence electron is same. So valency will also remains the same. Okay.